Good afternoon, and thank you all for joining the call to review the electromagnetic transient model requirements. My name is Christina Osborne. I work in ISO Stakeholder Affairs. I'll be the meeting facilitator. Sanjay Zhu from ISO's Regional Transmission South Group will be presenting the requirements. And also on the speaker line from the Regional Transmission Planning Group, we have Ibrahim Rahimi, and from Regulatory Contracts is Riddhi Ray. They're here to respond to questions, help Sanjay. And then, so the presentation that we're going to be reviewing is out on the miscellaneous stakeholder meetings webpage. So you can actually find that by going to the Stay Informed tab at the top of CAISO's homepage. And you'll see meetings and events, and there is a link for miscellaneous stakeholder meetings. So the presentation is posted out there. We're also recording the meeting, and we do make those recordings available to stakeholders for a limited time. It will be posted in the same location as the presentation. We will be pausing for questions kind of throughout the presentation today. So if you do have a question or a comment, you can raise your hand by pressing pound 2. We just ask that you please state your name and affiliation first. So I think Riddhi Ray is going to get us started, and then Sanjay will get going into the presentation. So Riddhi, go ahead.
Thanks, Christina. Can you hear me okay?
Yes.
All right. Yeah, I'll give a quick introduction of for the purpose of this call and some additional context so it's clear to our participants what we are trying to address, and I'll hand it over to Sanjay after that. Last year, so just to step back, the generator modeling requirements, specifically what we are discussing today, they are established under Section 10 of our BPM for the transmission planning process. We started this process in 2018, where we have been requesting technical data as well as models, including EMP models from existing and operational units that are connected to the ISO grid or to the distribution systems of our participating transmission owners. Since then, our understanding of the EMP models has evolved significantly, and last year we expanded our requirements for requesting EMP models to require all inverter-based resources that belong to Category 1 and Category 2 of the generator modeling program, which is basically every generator that has a gross capacity of 10 MVA and above and is connected at 60 kV and above. We also expanded the EMP modeling guide, which has been on our website, and since then, some of our understanding has evolved. So what we are trying to do today is provide additional clarification on how we want these models to be provided to us, as well as more transparency in the review that the ISO conducts for assessing these models, which is what Sanju has captured in this additional tab in the generator data spreadsheet, which focuses specifically on the review of EMP models for IDRs and identifies all the criteria that we use in that review. So it's not an expansion of the technical requirements, but a clarification as well as additional transparency that we want to provide to our participants. So just keep that in mind as we go through this call. Sanju, I'll hand it over to you now. Thank you.
Okay, thank you, Riddhi. So good afternoon. This is Sanjay Zhu from ISO. So I'll walk you through the EMT model requirements. First, some background. Probably everyone is familiar with the EMT studies for subsynchronous resonance purpose that has been there for decades. What is new is the expanded EMT studies for high IBR resources. So in the recent years, especially in ISO control grid, we have a huge increase of IBR resources, and the shift of resource mix really requires we expand EMT studies to cover more that cannot be captured by the positive sequence stability study. So that's why we are changing the EMT model requirement. We extend the EMT requirement to all IBRs in in category 1 and 2. We will show the details later. So the EMT studies can capture very fast transient. It can represent the power system at all frequencies. So that's the primary reason that we need EMT model for IVR. And some examples of EMT studies are unbalanced fault analysis, high frequency transient analysis, and subsynchronous oscillation analysis, fast control interaction with nearby devices and generation. This is more important for the IVR today. The next slide, please. So which resources must submit EMT model? Really already mentioned, if you can memorize that instantaneously here, you can see it here. If the resource is connecting to facility 60 kV or above, and the individual resource is greater than 10 MVA, or aggregate resource is greater than 20 MVA, then it might be subject to EMT model. And additional requirement, if it is a synchronous generator, it must, and close to series compensator line, then it must submit EMT model. Then all asynchronous generator must submit EMT model, with exception for type 1 and type 2 wind turbines. Type 1 and type 2, those are very old legacy wind farms. We don't require EMT model for them. Next slide, please. So the timeline, we have been requesting EMT model since the beginning of this BPM GEM model program, and that's in 2018. So at the beginning, there was very limited number of resources that were required EMT model. Then later on, we changed the requirement, expand to all IBR category 1 and 2. So now more generators are subject to this requirement. We have already received many EMT models from the generator owners. As we review, we also learn, and we have identified issues, and we have learned how to review those models. So we update the modeling requirement document. We have a newer version posted on ISO website. So for every resource that is required to submit EMT model, you should have received a notification from ISO with your deadline. So that includes all the catch-up information deadline for the phase 1 to 4 before we expand the EMT model requirement. Next slide, please. Okay, so that's the link. You can see this document for the details of everything we talked about here today is in that document. Next slide, please. Okay, let's pause here. So that's the process. Does anyone have any questions?
So again, if you have a question, please press pound 2 to raise your hand. And Adam, let me know if anybody enters the queue.
All right, that I will. I'm not yet seeing any questions in the queue yet.
Okay, good. Let's continue then. So let's get into the details of the EMT model submission. So what do you need to submit? First, documents. Okay, you need to tell us how to use the model, and so please include the documents, and we'll provide the details what should be in that document. Second, of course, is the model itself. It is a complete test case with all the devices modeled from the generating facility all the way up to the point of interconnection. So that PISCAD model will include all the PISCAD workspace and project files, all the supporting library files, and the configuration files. And last, we have developed this EMT model checklist. Please fill out this checklist and submit that together with the documents and the model itself. So this is the checklist for the model submission. We ask you to tell us which file you are submitting and a brief description of each file. Then you have to self-check, and you need to confirm if the model, the test case you submit include areas, include site-specific plant representation. That means that you don't just take the model from the manufacturer, submit to us. You need to take the model from manufacturer, customize it to your project, make everything site-specific, then provide to us. And then answer the other questions as model align with the single line diagram. So whatever showing on your single line diagram should be reflected in the EMT model. It has to be from the inverters or from the generators all the way to the point of interconnection. So you need to make sure you can answer yes to those questions before you make a submission. Next page, next slide. So regarding the documentation, you should include the following information in there. So this will first, be very clear what you are submitting. And second, it helps us a lot. So it's very hard to read a EMT model without any documentation because it's a black box and every model is different. We have to look for information. So we do ask you to provide the documentation. First, you tell us what's the vendor name and the version of the model. So we'll compare to the actual model, make sure you submit the right version. And the list and the description of the files being submitted. It should include the instruction for setup and running the model. So any particular requirement to any library we need to link, you should provide a clear instruction. Any model limitations, and you should clearly indicate what's the lowest grade strength this model is designed for. So we don't have a requirement at what grade strength the model should be, but we want to know what's the limitation of your model. If it's a short circuit ratio of 1, then put 1. If it's 2, it's 2. But we just want you to tell us what's that limit. And also tell us if the model is real code or not, since they are all black box. We don't know what's inside. And list and describe all the control functions and associated parameters that we can change. So tell us, okay, you have those control options and how to change the parameters associated with those controls. And list and description of all the protections. So whatever the protections modeled in the EMT model, make a list of that, and also tell us how to change settings for those. It might be some are actually in the configuration file, some might be in the model itself, and some model even doesn't let us change any of the protection settings. Whatever the model does, tell us. Next slide.
Sanjay, I don't know if you saw the question in the chat before we move on. It's from Gary Bishop asking, do we need to create an EMT model that was already submitted recently, so in the last year plus or minus, or are those submittals already sufficient?
Well, the models that are already submitted, we are reviewing them. Then we will return with those comments. So, for example, we'll say, please fill out this checklist and telling us those. So you will, if we can figure out everything is perfect, then we will just approve the model. But usually that won't be the case. So if you have already submitted, you don't need to do another submission right now. You can wait for our response. We will tell you what information is missing, and we need those information to be submitted before we can continue reviewing.
Great. Hopefully that answers your question, Gary. We'll go ahead and move on.
Yeah, so that's also the documentation should include a description of test case and make so how you have configured it according to the site-specific equipment. So that you should tell us if you have scaled it up to matching the number of inverters. For example, you have changed those. You have set the parameters in a way that matches your actual plant. then in the documentation, you should also include some tests. It's not just the document you get from the manufacturer. Actually, you have run this PSCAD model for your plant. So we'll ask you to show some balance fault test using the model, and also show voltage reactive power reference step change test, frequency active power reference step change test. So most of the category 1 and category 2, they are required to do the mod 26, mod 27 test. So mod 26, 27 include those voltage, typically will include the voltage reference step change, frequency step change test. So you usually mod 26, mod 27, you compare the positive sequence model simulation with the measured data. And we want you to expand that to also include some model validation and the benchmarking with the EMT. So it's very similar to what you do with mod 26, mod 27, when you compare your EMT simulation results against your field test. And they shouldn't be because the field test is available to use under that mod 26, 27 requirement already. So all you need is to add another simulation result into that comparison. And if you use real code, then no, we will not ask for that benchmark. Okay, thank you. Next slide. So this is the checklist for documentation requirement. And for the support, on the supporting documentation section, you list all the documents you provided, then answer the questions. So does the documentation include instructions for setup and running the model? Does the documentation provide a clear way to identify site-specific settings and equipment? So you should answer yes to the question before you submit the model to us. Next.
Other on the submission process before we move on to the requirements? Again, press #2. There's a question in the chat. So Adam, I don't know if we have anybody in the queue, but I'll go ahead and read the chat question from Mason. Sorry, I can't see, this print is kind of small. So asking, what happens if you find discrepancies between the mod 026, 027 results against EMT model? Are we supposed to change parameter and positive sequence model to make the results match with EMT model?
Yeah, mod 26, 27, you have field test results. So if the EMT model, the positive sequence model, and the field test, they don't all match up, then the field test data is the reference. Well, then the other two models should both produce results that is comparable to the field test. So it could be, either one could be wrong, either EMT model or the positive sequence model.
And there was another question that came through on the chat. Adam, do we have anybody in the queue?
We do have a person in the queue.
Okay. Let me read the chat question, and then we'll go to the phone line. So I think it's Farshid. If the manufacturer doesn't provide the model and generic model is developed, do we need to perform the benchmarking?
Yes, definitely. That's the benchmarking is for. If you are providing generic model, we don't need to know that generic model is a good representation of your plant. If you are providing real code model, then benchmarking may not be required.
Great, thanks, Sanji. So we'll go ahead and go to the phone line.
All righty. Caller, your line is being unmuted. Please go ahead. And just a reminder to the caller to take your personal device off mute.
Hi there. I just had a question on that mod 2627 verification results. So as we know, on mod 2627, we are not validating all of the parameters. For example, if the power ramp tracker in the REGCA model if, let's say, a value has been provided as a value of 1, and we see that the power is tracking with the ramper in the positive sequence model, but in EMT model, we see a faster response, are we supposed to go back to positive sequence and match it? I agree with you that the mod 2627 is against the stage test field results, but those are all we are validating with mod 2627 are REPCA or REPCD parameters, like the plant controller parameters. You are not changing anything inside the next second generation model that's being provided by the O&M, right? So if, for example, we see a discrepancy between EMT model on a megawatt recovery after the fault between the positive sequence model and the EMT model, are we supposed to go back to, per se, REGCA and change a parameter RRPWR, ramp tracker, or no? Which model I'm trying to say that which model should we rely on? Or just we show the discrepancy in a submittal report? Is that I'm a little bit unclear on what will be the final decision on that.
If you are talking about just the difference between the positive sequence model and the EMT model, for example, we run a 3-phase fault, that's not part of the mod 2627 test. And there will be discrepancy. So first thing is you contact the manufacturer as long as that discrepancy can be explained, because the positive sequence model has certain limitations. So it doesn't represent every single detail, but EMT model is supposed to have more details represented. So as long as that discrepancy can be explained, you don't need to change the model. But it could be one of the model is right that there's no reasonable explanation for the discrepancy, then we would ask you to contact the manufacturer to correct either the positive sequence or the EMT. And generally, we think EMT is more accurate, so it's positive sequence model, that's one.
Okay. We just make that assumption that EMT is more accurate, but any changes on the parameters that haven't been verified with the field stage test need to be run by manufacturer, and they would tell us if they're fine with making the change and whatnot, right?
Yeah, that's right. Sometimes we tell you, no, it's because some parameter we can't model in the positive sequence, so we let go. So those are okay. I
have one more, if you don't mind. I have one short question. So at the beginning, you mentioned that obviously when the GO is getting the black box model from the O&M, they need to make it customized according to the site and submit it to California ISO. Does that mean that the plant controller, as you know, a lot of these category 1 and 2, they have a main plant controller that is communicating with the inverters for voltage control, power factor control. Are we supposed to build that plant controller as a submittal too, or anything can be handled through the inverter, like all the voltage control and all of the sliders with the P and Q and everything else is just, as long as we get the same response, do you need to kind of mimic that plant controller that is sitting at the POI2 in the PSCAP model?
Yes, we require that the power plant controller model included, and the setup should match your actual plant.
Actual plant presentation. Okay, perfect. Thank you so much.
Any other questions in the phone queue?
We do not have any additional questions in the phone queue at this time.
Okay. We did have another chat question asking about the SSO analysis and if this is a requirement for wind farms only.
The SSO, the subsystem oscillation, no, it's not just for wind farm. We run that for all IDR close to series compensated lines, include solar PV or even batteries.
Okay, hopefully that answers your question. I don't think there are any other questions in the queue. Is that correct, Adam?
That is correct.
Okay.
Somebody.
Yeah, tried. So you can raise your hand by pressing pound 2, Farshid, so you may want to try it again. Or maybe your question was already answered in chat. just it. Okay. All right, we'll move on to modeling requirements. So Shanji, go ahead.
Okay, so next slide. Okay, so we will first talk about synchronous induction generators. It's relatively easy comparing to IBRs. So we will have EMT model details required for synchronous and induction generators if they are close to series compensated line. So these apply to any combustion turbine generator, steam turbine generator, hydro. But type 1 and 2 are exempt. We don't require EMT model for those. Next page. So what do you need to submit? It's similar to the dynamic model, but in addition to the regular dynamic model, the generator model, exciter, governor, PSS, you need to include a multi-mass torsional shaft interface model. So this is the model that's in addition to the regular dynamic model. This must be included. This is required for SSR type of study. Then also in general, so okay, that's fine. So include the machine saturation and the magnetizing curve. Next slide. So you can represent you can submit a model either in the PISCAT library using PISCAT library block, or you can have a user written model. Actually, if the PISCAT, you can there's a function you can translate the model in PSSE format into the PISCAT format, but there's no translation for PSF model format yet, I think. But people do use that. So the PSSE, PSF dynamic model for single generator, the conversion is quite easy. So you may be able, I think you should be able to use the eTrans function to directly import the PSSE model into PISCAT, and that's probably the easiest way to handle that. And you should include model parameters that reflect actual installed settings in the field and not the manufacturer default parameters. So this is true for everything we are talking here. We'll repeat that again and again. And you will represent the generator grounding system, represent all protections, and represent the dynamic devices in the plant. Next slide, please. Then that's all for synchronous generator. It's quite straightforward. Then for inverter-based generator, which is the majority of the results we have today, that will need to submit the EMT model. That includes solar PV and battery and type 3 and 4 wind turbines. Next slide, please. So you need to model the full detailed inner control loop of the power electronics. So the full IGBT representation is preferred, but the average representation is also acceptable, as long as it keeps the detail in the inner control loop and DC side protection. And we highly recommend to use real code. So that is the firmware code directly being packed into that black box model. Also include all plant level controllers, not just the inverter control. We require plant level controllers to be included. So they could include external voltage controllers, plant level controllers, any customized phase lock loop system, and your right through controllers. And if you have sub-synchronous control interaction damping controllers, include it. Basically everything inside your plant that's doing some control function, you should have them in the model. And also, if multiple plants are controlled by a common plant and common controller, we want to see that. So our model request is going by resource. Each individual resource receives one model request, and you submit a model for that resource. But it's possible you have several resources inside the same plant, and they are under some common control. If that happens, you should indicate that. And you may even just, submit the whole thing together, several resources, as long as we are clear, which one is which. And also emphasize this one more time: parameter should match what's installed in the field, not manufacturer default. Next slide, please. And so sometimes, people don't pay much attention, but we do require you represent all the protections in detail. So that's very important to us. So we know it will be tripped under certain conditions, and we can capture that in our study. Represent all the dynamic reactive devices, including automatically controlled capacitors and reactors, if applicable. Include representation of the transformer magnetizing curve, and then be configured to match the site-specific equipment setting. Next slide. Okay, so this is the checklist that you will have to fill out for model accuracy purpose. So most of the questions are quite straightforward. Some questions are for information purpose. So on this checklist, it's not required to have an answer yes to every single question. For example, the first one, we ask you to tell us whether it used real code or not. Both yes and no are valid answer. We just want to know yes or no. So if not using real code, there is a model validation report included. So if you do not use real code, we want the model validation. That's when we talk about the benchmarking against model 26, 27 measurement, and also benchmarking between the EMT and the positive sequence. And does the model include the plant PPC, plant level controller, and provide a list of all the controllers you have installed in the plant? So you should answer yes to this one, otherwise it's not a complaint. It's not a complete submission. Does the plant level controller control generating resources other than the subject resource? So that's the thing I talked about. There could be multiple resources under the same plant controller. So you tell us, and this also is for information. Both yes or no, yes, no are valid answers. The operation modes which require system-specific adjustment accessible. So typically in the plant you can choose. The manufacturer will let you choose one of the operating mode. For example, for the Q control, you can do Q control, you can do power factor control, you can do voltage control. So those modes should be accessible to you, and you already made that adjustment to match your plant. So you just tell us if you have done that. And for this one, the answer should be yes. Does the model include automatically controlled capacitor or reactor? So this is for information. Yes or no answer are valid. The transformer magnetizing curve included, and this one you tell us yes or no. We have seen that most people just use the default transformer magnetizing curve. We have been accepting that. Does the model include pertinent to electrical and mechanical features such as gearbox? So this is really for the wind turbines. So if it's a solar PV or battery, you can answer not applicable. Then for wind turbine, you should answer yes. You need to answer yes for the submission. All protection which could impact right-through performance model in detail, and list those protections. So the answer to this question should be yes, and you should tell us what protections are in the model. Has the model been validated at different operating conditions ranging from minimum power to maximum power? Yeah, this requires yes answer. You should test your model at several different operating conditions before you submit to us. Is the model configured for the specific site being evaluated as far as they are known? Yeah, this also requires answer of yes. Next slide, please.
I think if you don't mind, let's go ahead and pause and see if there are any questions on the model requirements. Yeah, so if you do have a question, press #2 to raise your hand, please.
All right, and we do have a question in the queue.
Thanks.
All right. Caller, your line is being unmuted. Please go ahead.
Hi. Thank you so much for this helpful presentation. My question basically goes back to the previous section, which we discussed about the benchmarking. We have faced some situation that we have some older plants that the manufacturer model or document is not available. So we have to start based on the generic model. Of course, the real code is preferred, or if the real code is not, at least developing the model based on the actual logic diagram and control diagrams of the system is preferred. But sometimes even those information is not available. So we have to proceed with some generic assumption and also using the RMS model at least as a base for the outer loop, not the inner loop, because they don't include the fast inner loop. In those situations, which we even do not know the control scheme of the inverter-based generation, what is the recommendation for the benchmarking? Is that enough if we basically develop the generic EMT model, which includes all the inner loop and more detail compared to RMS model, and just benchmark it against the dynamic data set that has been tuned based on the mod test or not? Thank you.
Yeah, so that's the first step you are going to do. So you just use the generic model, tune the parameters such that it matches the positive sequence model for now. So, and then in the long run, we will recommend you to collect disturbance data. If there's actual system event happen near your plant, then use that disturbance data for further refinement. We don't know when that will happen. So for model validation purpose, we will accept the model after the benchmarking with positive sequence. In the future, we'll just keep an eye on any system events that could be used to further validate and tune the model.
But at the moment, benchmarking against the RMS model, which has been tuned based on the mod test.
Yeah, that's acceptable for the time being.
Okay.
Yeah.
Thank you so much.
Adam, do we have anybody else in the queue? We do have a chat question here.
We do not have any questions in the queue at this time.
So there's a question in the chat. There are inverters out there that OEM is out of business and no, PSCAD, I'm unfamiliar with these terms, model can be provided. What should be done in that case?
Yeah, so that's what we were just talking about. You will just make use of the generic model available through PSCAD. Then try to fit the parameter to your positive sequence model and performance, and then use that for now. Then in the future, if there is a system event, then you can further refine your model based on the actual response during the disturbance.
Great, thank you. I think that's all the questions we have for now. Adam, is anybody else in the queue?
We do not currently have anyone in the queue.
All right, so we'll go ahead and move on.
Okay, next slide. So now we are moving to the usability requirements section. Usability requirements include the first, it's a time step it should be capable of running at time steps between 10 milliseconds to 20. The reason is that the purpose of asking EMT model is to perform at least a local system study. We'll put all the EMT model together and run a system study. And if each model is at different time steps, like if it requires 1 millisecond, then one model requires that will slow down the whole simulation. And EMT model simulation is very slow. So at a smaller time step, it is almost impractical to perform a system study. So that's why we require the EMT model to be capable of running at least 10 milliseconds. Now, of course, it should initialize itself. We ask it to reinitialize itself within 5 seconds. Taking longer than that is considered a bad model development. And then after the initialization, the model should be able to ramp up to the full output and settles there. Now, it should allow the active power capacity of the model to be scaled if using the same inverter, and also we scale up the number of inverters. Should be able to scale up the collector and time-bound transformer model. Then it should have the ability to dispatch output anywhere between 0 and the maximum output. The next slide. And the model you submit should be set up as a single machine infinity bus representation of for the system side. So it's a voltage source on system side with some impedance that can be configured and adjusted to represent short circuit ratio. So this is an example. You have a grid equivalent there, and the SCR, the SP plant those are set based on the SP plant is set based on the plant. Then SCR and the XR ratio, those are adjustable. So that you see the slider on the right, so we can test the model under different SAR. Also, this one, like the reference, can be adjustable. Next slide. And so this is talking about all the external reference values should be adjustable, so we can easily change the voltage reference or frequency reference or the megawatt set point. So during the test, we can, when we validate the model, we can run those tests to do a step change of the reference or set point. So we require you to include this feature. When you directly get a model from manufacturer, those are probably not there. So that's why you have to do something to the manufacturer model. You have to add those to the manufacturer model. Next slide.
Sure. Yeah, Sanjay, I don't want to get too far ahead. There were a couple of chat questions. I think some folks are having difficulty raising their hands. So this is from a previous slide. Does this requirement deal with ride-through only, or does it also address frequency or voltage response?
It's both. So it's not just ride-through. Ride-through is one thing we're going to test. We're also validating the frequency and voltage response.
Okay, hopefully that answers your question. Somebody just asked where they could find the model accuracy checklist.
This checklist is a part of the model request we sent to you. So the model request sent to you is a big spreadsheet. It has several tabs. One of the tabs is this checklist.
Okay, thank you. These are all the chat questions.
Okay, so also we require, you show all the protection models, and we have a way to enable and disable each protection. The other control options should be like if you do have some other control, like a subsynchronous control interaction controller, then we should have a way to disable that. Next slide.
Okay, one more question in the chat. They asked, are there any WEC testing standards to adhere to?
No, there is no EMT testing, EMT model standard so far. All the WEC standards is for the positive sequence. Okay, so yeah, that's all for the usability. I guess we will, no more question. We will move on to the efficiency. The model we must be compiled using Intel Fortran compiler version 12 and higher, and must be compatible with the PSCAT version 4.3, 4.6.3 or higher, and initialize as quickly as possible, less than 5 seconds. It should support multiple instances of its own definition in the same simulation case. That means we can make a copy of this inverter model, or then paste it into the same case, and it will work. Support the PSCAT time snapshot and multiple run feature. Allow replication in different PSCAT case or libraries through the copy transfer. So we can copy transfer the model into another case. So that is important. When we build a system case, they will be copy transferred all into the one case. Do not use multiple layers in the PSCAT environment, including disabled layers. Just put everything on the same layer. Next slide. So this is checklist for the model usability. You'll answer each question. Again, some must be yes, some are more for information. Let's see which one must be yes. Personal control hardware options are accessible to the users. They should be a yes. Are there diagnostic flags accessible? Please provide description of the diagnostic flag below. This could be yes or no, but actually we are just asking you, but we do want to see those diagnostic flags if possible. You know, when it trips, we need to know why it trips. The next question is not even yes, no, just purely for information. Tell us the great strength that the model is designed for. And next one, does the model run at a time step between 10 to 20 milliseconds? And please specify the time step. So tell us yes or no. If it's a no, we will work with you to find if it's possible to use between 10 to 20 milliseconds. So no doesn't really mean this model is not accepted. It means we need to have further work on that. We would prefer to have the model running at the time step greater than 10 milliseconds. Is the model restricted to the time step? Yeah, so if the above is yes, we don't need to answer this. Sorry. If the above, let me check. If the model restricted to time step provided, yeah. Also, you enter the time step for the previous question. Then if it's not between 10 and 20, you tell us whether that is restricted to the one you provided. For example, if you say it is 5 milliseconds, then we want to know if it has to be 5 milliseconds or there's some room to change that. Does the model initialize itself? This must be yes. Does the model initialize to PQ or read in 5 seconds? This must be yes. Does the model accept external reference variable for active? This must be yes. Could the external reference be changed dynamically during the simulation? This should be a yes. So the protection models disabled for troubleshooting, they should be yes. Is the active power capability scalable? This also should be yes. Is the active power dispatchable? It should be yes. Next. And then is that Fortran, Intel Fortran version 12 and above? Then it's yes, must be yes. And PSCAT version 4.6.3 must be yes. Support multiple instances of its own? This should be yes. Does model support snapshot? This should be yes. Does model support multiple run? It should be yes. And does model support copy transfer? It should be yes. And it does not use layer functionality. It should be yes. So that's all on the. I think that's all for the usability.
Yep. Let's just see if there are any questions. Again, press pound 2 if you have a question.
All right.
No
I'm
questions.
not yet seeing any questions in the queue.
Okay. I guess we'll move on.
Then for the performance, so we will run model performance tests similar to what we do with the positive sequence model. So the test with like a flat run, that is to verify initialization, verify the clean voltage and the current waveform. So we are going to look at the three-phase waveform and make sure it is a clean waveform with minimum distortion. Then the bump test is a three-phase fault at the POI with a typical fault clearing time. So it's 230 kV or 500 kV, and the fault is 4 cycles. So we'll test that at a short circuit ratio of 3. And we do require your model could work at this 3, but typically EMT model can work at SDR much lower than this. It's based on the condition we have in our system. We feel like we'll test model at SDR 3. That's reasonable, at least for now. So for the bump test, it needs to be stable. Also, we will compare the bump test against the positive sequence model test. So they will never be the same, but as long as there's a pretty reasonable match. So like you can see, like within the same time frame, the P and Q recovers, and then general trends during the transient are the same. That will be fine. If we see some significant discrepancy, we would ask for explanation. Some discrepancies are reasonable due to model limitation. Some could be modeling error.
Andre, we did receive a chat question.
Okay,
you see it?
Yeah. Okay. Yeah. Go ahead. You can read to everyone if you want.
Yeah. Should these test results be provided to CAISO? If yes, is there a template document?
Yeah, sorry, I forgot to mention that those are tests performed by the ISO. We do not require you to perform the test, but it will be better, since we are going to do this, it will be better for you to do that on your end as well. Then you will have higher confidence that your models are good, will pass the review. And also those are part of the checklist. So the checklist has 2 sections. One section we require your input. The other section that's our review only. We don't require your input, but the checklist, regardless it is showing in your data request, GModel request spreadsheet. You will see what we are going to do exactly through all those tests. When we review, we'll enter the test results in the comment box, and when that's sent back to you, you will see all those.
Thank you.
And then we'll do voltage or reactive power reference setting depending on your control mode. We'll verify voltage control performance. See how long does it take to reach the new set point, and and other control performance. And so for this, because the Model 26 usually it has the same test like this, we will check that against Model 26 test performance. Mostly, we're looking for, how long it takes to reach to settle on the new point. Where we have seen some Model 26 shows very slow response, but the EMT model shows very fast response. So that kind of indicates the plant controller is not modeled properly. Usually the inverters are very fast. If the plant controller slows it down, then for a small disturbance, just a reference step change, it should be governed by plant controller response. So a slow response is reasonable and it's shown in the field test. And the very fast control response in the EMT model is questionable. Also, the frequency or active power reference step change will verify the frequency of active power control performance, then compare that against the Model 27 test report and then see the response time. And a voltage rise-through test, this is to verify protection settings, verify that the protection treats the inverters properly. Also, we want to see the protection diagnostic signal when the generator is tripped. There should be an indication why it is tripped. But there is a question after the fault clearing times available. Or we can use generic based on. Yeah, I think you can use generic based on kV levels. Usually it's the 4 cycles. Under low voltage, 6 kV it might be a little bit longer. You can contact your. You can send a question if you're not sure what to use. You can send an email. Like email will tell you. So continuing with the performance test by ISO. So you see here that this is a checklist I mentioned earlier. So this one is a little bit different from the ones we showed before. On the left side, that's where the generator owner will answer. Actually now you don't answer anything. It's only the right side of the PTO and ISO will choose yes, no, not applicable. So we'll run those tests, and you know what we run, and you can do the same thing yourself. So the test to summarize here: instantaneous voltage and the current waveforms have minimum distortion and no oscillation. So this need to be yes. Model is able to rise through and recover from a temporary. Yeah, this one says 6 cycle. Actually, I think that's not right. Most of tests are 4 cycle. We can correct that. 4 cycle, 0 impedance 3-phase fault at the high side of the station transformer with. I think this description might be a little bit off. We apply that at the POI with SCR equal to 3. But it's not at the high side of station transformer. It is at the other end of the gen type. So this has to be answered yes. The model responds to step change in PPC voltage reaching 90% of the new value. So it says one between. So this one we could say yes or no. Both are valid. So it says between 1 and 10 seconds, but actually what we are looking for is the actual response from the plant. If the plant, the Mod 26 report shows a duration longer than 10 seconds, then this should be longer than 10 seconds as long as it kind of matches the Mod 26. The next one is the active power set point step change. It says reaching 90% of the new value between 1 and 10 seconds in the testing with SCR equal to 3. Similarly, the answer could be yes or no. bottom line, it should match the Model 27 test. Model trips or blocks when terminal voltage variance is about 1.3 per unit volt. So this could also be yes or no. But typically it should be yes because this voltage no usually at least I have seen only one or two exceptions that they will trip for voltage, high voltage at 1.3. Very rarely that it can stand voltage higher than 1.3 per unit. Model trips or blocks when terminal voltage falls below the protection settings. So this is yes. So we are going to look for the protection settings. You submit it as the overall package. So that's also in the positive sequence model. Then we will in the test we will make the voltage falls below that threshold, and then for a certain time that will exceed your protection setting. Then we are expecting to see that the generator is tripped. So this answer should be yes. Model clearly displays trip diagnostic signals indicating the status of all. So this one is hopefully yes. Some model because the black box nature they don't have diagnostic signal. We'll try to work out with you. So understand that you may have to spend a lot of effort to add those features.
I think that's all you have.
Yeah. There's a question, do you have any requirement on momentary cessation? So we have momentary cessation as an interconnection requirement. This is for modeling. So we just want you to show if the generator, the inverters do momentary cessation, it should be reflected in here in the model. So that's why we want you to list all the protection that include momentary cessation, and we will try to verify that. We probably don't have a particular task on this checklist to verify momentary cessation. That's something we can consider to add to the checklist.
Okay, and I think that we have somebody in the queue. Is that correct, Adam? Just one person?
That is correct.
Okay. Again, press pound 2 if you have a question or comment. So we'll go ahead and go to the...
Sure. Caller, your line is being unmuted. Please go ahead.
Hello there again. Thank you so much for the good information. Couple questions. One is regarding the SCR. So if I understand correctly, all we need to do is just running the model with as low as the SCR of 3. We do not need to know the exact strength of the system and calculate the SCR. No, as long as we can show good response with the SCR of 3, that suffices for in-CAISO requirements?
Yeah, we are not asking you to calculate the system SCR. If the model works SCR at 3, you will pass the model validation. We chose 3 because we did an estimate of the system strength, and the lowest is slightly higher than 3.
Okay, perfect. So that's one. Then the other one, I've seen it in the EMT modeling requirements by California ISO. One of the items is including the transformer magnetization curve. Does that mean that we need to include the transformer magnetization curve that comes from the OEM, or no, we need to model let's say go with the basic model in, for example, PSCAD and use the match that function and include that as a report or as an appendix in the report? Like, what exactly does that mean, that include the magnetization? Do you just want to know that the transformer magnetization has been modeled properly in PSCAD, or no, you're just after the curve from the OEM?
Yeah, we want you to include that magnetizing curve in the PSCAD transformer model. So there's a place you specify the curve. You can either select, you put it in there.
Just include it in there. You model it correctly. That's all. Okay, perfect. Thank you.
Mm-hmm.
Any other questions in the queue, Adam?
We do not have any additional questions in the queue at this time.
Okay, finally, then there's some contact information. If you have further questions, comments, you can always contact ISO at gridmodelingdata@cnso.com. Then also you can contact your interconnecting PTO at those mailboxes. And always, copy ISO when you send to those PTOs.
Great, and I think that's all we have today. So are there any questions before we conclude? Or do you have anything to add, Sanjay, before we conclude?
No, I think we have PTOs on the line. So if they have anything to add.
Sure. Again, press pound 2 to enter the queue. We'll give it just a few moments.
Mm-hmm.
All right, I'm not seeing any additional questions in the queue at this time.
Okay. Well, that's all we have for today. Really appreciate your participation. And again, there's a list of contacts in this presentation, so feel free to reach out to this email. So thank you. Enjoy the rest of your day. Thanks for your help, Adam. Appreciate it. And thank you, Sanjay.
Thank you.
Thank you as well. Ladies and gentlemen, this concludes our call. Thank you for using AT&T Event Conferencing Enhanced. You may now disconnect.